Next, let's look at an example of a function where they've given us a graph. So functions and graphs are intrinsically related to each other. The x values represent the inputs, the y values represent the outputs, as we've said. And then the curve, the shape of the graph, as we draw it, represents the definition of the function. So the three parts of the function are shown here. And if I know a point that's on my graph, on my curve, that means that I know a matching pair of inputs and outputs. So this is an input-output pair. And so too is this. This is another input-output pair. And what this tells me is that when x is equal to -2, y is equal to 6. And this other point tells me that when x is equal to 1, y is 3. So if I look at the definition of my function up here with the formula, and they've used a different letter, not f of x, they've used g of x, but you can ignore that. That's absolutely doesn't matter what letter we use there. So I'm going to say y is equal to ax squared plus bx minus 2. We don't know the values of a and b, those are unknowns, and x is our input and y is our output. So we know from the first point, from the point -2, 6, that if we sub in x equals -2, we can also sub in y equals 6. I'm going to write it with the y on the other side of the equation. So we get a times x squared plus b times x minus 2 equal to 6. And we'll tidy that up a little bit, and that becomes 4a minus 2b, and we'll bring the -2 to the other side, equals 8. And because I can, I'll divide across by 2. So if you ever can simplify an equation like this, go ahead and do that. 2a minus b is equal to 4. So I end up with an equation. Now I'm used to seeing these kinds of things, so I know already that what they're going to be asking me to do is simultaneous equations. How could you tell yourselves from looking at something like that? Well, there's two unknowns. Two unknowns and two pieces of information. It's likely to be a simultaneous equations question. Then we have 1, 3, and we sub in x equals 1 and y equals 3, giving me a times 1 squared plus b times 1 minus 2 equal to 3. So all we're doing is following the pattern of the formula, replacing the x and the y values. Tidying that up, we get a plus b equals, I'll bring the -2 over, equals 5. That's the second equation. So I have two equations and two unknowns, and I need to solve those simultaneously. And it looks like they will solve nicely straight away. We don't even have to change signs because the b terms are already set up for cancelling. So equation 1, let's write them one above the other. 2a minus b equals 4. A plus b equals 5. B cancels. 3a is equal to 9. And a is equal to 3. Then I'll sub that back in. Sub in a equals 3 into equation 2. It's just a bit easier. It doesn't matter which one, of course. Into equation 2. And I'll get my b value then. 3 plus b is equal to 5, so b is equal to 2. And there we go. We have our answer. Sorry, that went off the screen a little bit. So my answer is that a is equal to 3 and b is equal to 2. Now, if there was going to be any follow-on questions, I'd want to put that information back into my formula, that g of x or y is equal to ax squared plus bx minus 2. We weren't asked for it in this question, but it's a good habit to get into. Okay, thank you.